Hello, sir. Hello. Hello.
Hello, sir.
Hello, Dr. Anand. Hello.
Yeah, yes, sir. I'm there.
Good. This is the SITAMS
Sir,
engineering
your
college.
voice is breaking.
So this is autonomous.
Sir, your voice is not audible.
Okay. Okay.
Is it from my side only or participants also? Or participants?
No. Why?
Okay.
Your voice is audible to me, sir.
Fine. Okay.
Yeah. Good morning to all of you, the participants, and welcome to Dr. Anand Kumar. Welcome to the SITAMS Engineering College, Autonomous NAC and NBA accredited. We are AICTE topic heading artificial intelligence and machine learning. So this is on the heading of explainable artificial intelligence and machine learning problems using Python and TensorFlow. Under this heading today, processing. So I'd like to give the Professor Lakshmi Narayan to introduce Lakshmi Narayan, sir. Please take over.
Okay, good morning. Good morning to resource person and all participants. So today, honorary resource person speaker, I am inviting Dr. Anand Kumar sir from National Institute of Technology, NITK, Surathkal. So now I would like to announce his achievements and about resource person. So he has expert in area like text analysis, NLP, information retrieval, machine learning, and deep learning. So many research projects he executed and acted as an investigated. So projects like computing tools for Tamil language learning, machine translation system for subtitles, paraphrase for Tamil, Dravidian WordNet, Malayalam WordNet, English to Indian language machine translation, creation of machine translation tools and resources for English to Dravidian languages. Then he guided one PhD student and 28 PG students. Then more than 24 conference publications he was done, and 10 journal publications and 4 book chapters he was done. And mainly his research contributions to NLP community is developed POS Tiger and Shankar for Tamil language, novel methods introduced for morphological analyzer using machine learning, web conjugator for Tamil, dependency parsers for Tamil, morphology based statistical machine translation for English to Tamil, paraphrase detection corpora created for Tamil and Malayalam languages, and many achievements he got. So one is received P.K. Das Memorial South Indians Best Faculty Award in 2017 from Nehru Group of Institution. Then Research Excellent Award he got during 2016 to 17 from Amita Vishwa Vidyapit in 2018. Then received the Young Scientist Award in 2016 in the area of NLP from Venus International. Then received prize in Icon NLP Tools Contest 2015. Then received the Best Paper Award in International Conference 2017 at Manipal University, and received the Best Paper Award in International Conference 2010 at IIT Kharagpur. Then invited to NLP Center at University of Moratuwa, Sri Lanka in 2018 for research talks and discussions. In 2017, he received 1 lakh funding from CIIL Mysore. Then developed linguistical tools and resources for Tamil and other languages. Then he participated in various international reputed shared talks, challenges, competitions. So these are the achievements what he has done. So with this, I am very glad and happy to inform Dr. Anand Kumar sir from NIT Surathkal to take over the session and to enlighten our participants. Thanking you, sir. Anand Kumar sir.
Yeah, thank you, sir. Thank you. Special thanks to Pawan, and then very sorry to participants to make you wait because due to some emergency meeting, so I couldn't start the session on time. fine. Okay. So directly I'll go to the session. I hope my voice is audible. If you have any problem in my voice, then feel free to stop me. So I want the session to be a little bit interactive. So I want active participants. I want active participation from you people. So I may ask a few questions, and then you try to interact with me as some chat box message is clear. Okay, fine. Okay, so try to interact with me. So then we can have a discussion also. So like that we can come with some research problem, or it will clear the doubts, and then it will enlighten the things. It should be like I don't want to be like a monotonous talk. So that's what it should be, like a brainstorming session. Fine. So when you're going to the session, so we're going to talk about deep learning for NLP. This is the roadmap of the presentation. So I'm going to take 2 sessions on this. Actually, first one I'm taking now, and then afternoon I'll just half an hour or 1 hour I'll just cover the theory, and then remaining hours will go to the demo and then other things. Afternoon. Now I'm going to cover that what is NLP, maybe the introduction to the NLP, or only 1 or 2 slides to the people who are all new to this area. And we'll see that what is deep learning, and then how can we connect NLP and deep learning, and what is the mechanism, what is the bridge between the connection. So that is called the word2vec. So that we will see that, and then the power of word numberings and some other interesting research problems also I would like to discuss with you people. Fine. So this is for the people who are new to language processing. So when you are saying natural language, it refers to the language spoken by people. So as you know that it's a language used by human to communication. So when we're talking about the processing, natural language processing, so it deals with some kind of analysis we are doing with respect to language. Okay, here I just ask a few questions. Okay, here I would like to ask a few questions that. So that you people are aware that languages like artificial languages. So this we are talking about the natural languages, example English, Tamil, Telugu, and all. And we are talking about something called artificial languages, C++, Java, and other things are there. Okay, so you are teachers, and then how do you feel that which language is easy to teach or easy to learn, the artificial languages or natural languages? Participants, quick response. Hello. Hello.
You proceed, sir.
Yeah, yes. Any answers from the participants? Some people responded as natural. Okay. Okay, fine. So I hope people are active. So when you are talking about that natural language, both languages having its own complexities, but compared to the advantage what we are having is, so the things what we are understanding is actually we are understanding using our brain. So our brain plays a major role in the understanding anything. So that gives the intelligence. So it depends on the complexity in the language. So preferably, if you see that artificial languages are not that much complex compared with the natural languages. I'll just come to the other question. So after explaining what is NLP, okay. So when you are saying NLP, so this is a multidisciplinary area where you are talking about AI and the computational linguistics, as well as the other allied areas from the control theory and other things. Okay. So when you are saying artificial intelligence, I want to spend some time on AI. So that's a current buzzword. So wherever if you are turning, and then you are people are working on AI, all the companies are pushing so much money on AI projects, and so much investments on AI projects. Why AI is popular? The first question. Other one is AI is not a new term to us. AI term coined in 1950. I hope I have that slide. Okay, we'll see that. We'll see that about the AI. I hope I have the slide for the A. Anyway, I'll explain that portion in the deep learning part. So now you just come to the goals of natural language processing. So I can divide the goals into 2. One is short-term goal, other one is a long-term goal, ultimate goal. My short-term goal, if you are asking, my short-term goal, NLP's short-term goal is actually to build a computer systems to process text and speech. When you are talking about NLP, the three main components. One is the text, other one is a speech, other one is, we can say, it's considered as a gesture. So when you are saying that text, so each language, if you are taking, suppose you are taking English, it won't text representation is there. And we have two things in for each language we have two components. One is actually we are speaking the language. It means that we are producing sound. So that is so I'm talking the language, and as well I'm talking in English, as I've written in English. So English has two forms to represent here, actually two main forms. Some languages, if we take that, the old languages, certain languages, they don't have the written forms. They will only have a spoken forms. So that kind of languages we call as endangered languages. But because written form is a document, written form will retain written form. Now you see that because of the internet, so it's easy to even though if someone want to smash your language, they cannot, because everything is there in the internet. So you have already uploaded enough content of your language, particularly Indian languages, in the internet. So no one can do anything now. But for the other endangered languages, they don't have a document. It means that they don't have a written script. So we are lucky that we have a written script. They don't have a written script. They know how to talk. Because if you closely see that, particularly in Tamil Nadu, we have seen that few people are, there are so many regions actually, people are talking a special kind of languages. You cannot understand the language. The language is sometimes to be a mixture of Kannada and Tamil. Sometimes the language look like Baduga and Tamil, like that. But if you are asking them to write, they don't have the written script for the language. But luckily, we have the written script for the language. Like in Orissa also, there are so many languages are there without writing script. Only they can they can communicate each other with that thing, but they don't have written script. But we are having a language with where we have a written script as well as that the spoken form also. Okay, so when you are saying that the one way is the written form is called the text, the spoken form is called speech or audio processing. The immediate goal is to process these two things intelligently. As I said, the third component, gesture can be considered as a third component. But the speciality of the gesture is it's not depending on any language. So I'm showing the number 2 as a gesture. Is it depending on something, any language? No, you can easily understand that. You don't want any language knowledge to understand these signals, gestures. Okay, so that is a one kind of the research in language processing. So why we are doing, what we are doing in natural language processing? A simple point I want to say that I explain what is artificial languages, what is natural languages. The languages spoken are spoken by human. Now, who invented who invented natural languages? Who invented artificial languages? Who invented natural languages and artificial languages? Participants?
Humans, sir.
Humans. We only invented. Okay. So why we invented a machine language? We already have one set of languages called human languages. Why we invented a machine language? To interact with machines. Am I correct? So what we are doing with the help of Java or Python. So you can, whatever interaction you are doing with the help of keyboard or mouse, it's only in the user interface. It's only the interface level. Really, you want to test the system's intelligence. You want to use the power of the computers and then the computing facilities and the algorithms, developed algorithms. You should have a skill of learning some language, computer programming language, to interact with the computers. So we humans invented the computer language to interact with the computers. Okay, fine. So what we are doing, so with that language, we are forcing humans to learn that language. If you want to interact with the system, if you want to develop an Android app, learn Android programming. If you want to develop a good machine learning project, if you want to develop a good machine learning system application, so learn Python. So like if you want to develop a high performance computing system within HPC platform, learn Spark or Scala. So like that, we are asking a human to learn this, learn this, learn this. So why, instead of asking a human, to learn that, okay, the person whom you are asking is a technological person, you are asking him to learn Python or Android programming. Suppose a layman who studied only up to 5th standard, 8th standard, who is very good in accessing working smartphone. After seeing all the interesting app and games, he got a idea to come up with a good application, to build an application for his own purpose or for a small society or any gaming application. So what is it possible for him to learn a language and then develop the systems? It's difficult because if you are talking to the students in your institute or the faculty members, they have known about some basics of programming, so they can easily learn that programming, I hope, and then they can do it. But for layman, it's difficult. So this is the problem is coming. And tomorrow, now if you are taking the faculty members, or I know few faculty members, they are very good in C and C++. No one can beat them in particularly in C. Even students or experts in working on an industry, they may fail to see that much. So they have that much depth understanding of C language, and then they can solve any kind of programming, they can build any kind of small application with the help of C functions. Okay, that is the case. Now you are saying that you are asking, after some time you are asking him to learn C++, then you are asking him to learn Java, now you are asking him to learn Python, tomorrow you may ask him to learn some other language. So like that human, instead of asking, instead of forcing a person, forcing a students to learn this language, that language, like that, why don't you ask computers to learn our natural language? This is called a natural language processing research. So instead of asking a human to learn artificial languages, we are asking a computers to learn natural languages. So you are telling computers, you see, I want to interact with you. So what I'm doing, I'm learning Python, and then I'm sitting and then I'm building application. So next time I won't learn your Python language, and then I will come and build the application. Next time what you should do is you should learn my language. You should learn Telugu or Tamil or English, and whatever instruction I'm giving in Tamil or Telugu, you should understand, and then you should execute accordingly. This is if that is succeed, that is called the natural language processing research. Okay, why we are doing this? This is the reason why what is NLP, and then why we are doing NLP research. Now I have a question to you people. What is the difference between natural languages and programming languages? I hope you have aware that what is a natural language and what is programming language. Now I'm asking that the difference. Can participants quickly answer? Post in a chat box. Work with computing systems. Natural language have some tones. Okay. The simple example in the representation level, I can say that I want more I want more clear explanation from other faculty members also. You just say your opinion. I'm not asking any tough questions. Natural languages, programming languages. I'm asking the difference. And I can just simply say that the representation level difference, I can say that natural languages are having a spoken form and text form. Programming languages only written form. There is no spoken form in the programming languages. Ambiguity. So Magesh Panchal, he answered correctly. So that is the thing. The ambiguity is a main problem in natural language. Artificial languages are logic based. Yeah. So logic based means we are giving instruction. Artificial languages, if I'm saying some statement in Python or Java, there will be always one meaning for that. There won't be any ambiguity. So my compiler it's easy for my compiler to understand that language, because it's no need to take any complex decision making process to understand the instructions whatever I'm giving. If I'm running the instruction for first time, it will do the same. Second time, do the same. Third time, do the same. Because my instructions are not ambiguous. Compiler cannot handle the ambiguous statements. But natural languages are highly ambiguous. So ambiguous means if you are writing a word, suppose I'm writing a word book, like that, if you are taking any sentence or any verse, there will be multiple meanings for that. Say, for example, word book. What are the multiple meanings for the word book? Participants? What are the multiple meanings for the word book? Participants, any answers?
Proceed, sir.
Yeah, I'm proceeding. I'm waiting for answers in chat box. Whether they are here, participants are other. Okay, whether Sanskrit is dedicated to computers are here. No, okay, that kind of questions will come back later. You just come to that question what I asked. What are the simple question I asked? No, what is that meaning for the word book? Two meanings are there for the word book. What are the meanings? No, that's what I said, that the session should be interactive. Otherwise, it will okay, fine. So someone
It
raised
volume
hand.
of
So
pages. Book is volume of pages.
book. Okay, so book means a textbook. Textbook you are saying. One more
volume
book is
of
there, no, sir?
intelligence. Yeah.
Yes, sir. Yes, sir. Fine. One more book is there. No, what is that, sir? Verb in sense of verb, ticket booking. So there are two meanings for the word book. So that is because one is for a textbook, other one is for booking, ticket booking. Fine. So like this makes the language processing as a complicated task. So this is a word level ambiguity. So there are different levels of ambiguity in natural language processing. After this, I just move to the deep learning part. So when you're talking about ambiguity, so you see here actually, this is called a phonetic level ambiguity. Same word, you can see here, the same word, you can write, say the same pronunciation, right, but three different words are there in that. Three different words with three different meanings. Three different words means three different spellings, three different meanings. But the pronunciation for all the three are same, right? If you are talking to Alexa, you are dictating, you are asking Alexa to write something or converting that to Telugu, you are saying right. So whether Alexa will understand whether you mean to say right, or you are saying right, or you are saying right. So this is the first level of basic level of ambiguity, phonetic ambiguity. Next one, if you see that lexical level ambiguity. So you can see here that book, word book, noun or verb. So that's I already said that it's a word level ambiguity. So word, multiple noun or verb are called grammar categories. Grammar categories or POS tagging. So this ambiguity is because of different grammar categories, not different grammar categories. Structural ambiguity. You can see here that this is an interesting one. Sentence level. I saw the man with the telescope. What are the meanings for this? Structural ambiguity. Any quick response in the chat box? What are the meanings for this? I saw the man with the telescope. I saw the man who is having telescope. I saw the man using telescope. So this is structural ambiguity. Semantic ambiguity. This semantic ambiguity is little bit close to lexical level ambiguity. The difference you should understand. This is lexical level ambiguity and this is semantic level ambiguity. In lexical level ambiguity, if you are taking a word, there will be two meanings. The reason is because of two different grammar categories. One category is noun, other category is verb. I have given an example book. Do you have any example for the lexical ambiguity? So the word ambiguity is because of grammar, two different grammar category. One is noun, one meaning, one is book, textbook you are saying, it's noun. Ticket booking, you mean to say that, then it's a verb. But in semantic level ambiguity, these two are, the reason is here, the same level of ambiguity. It means that same post category, noun or verb, same post category, but two different meaning. There are two meanings for the word. The word belong to noun only, but there are two meanings. Say for the word dish, physical plate, menu item. Other examples I'll say plant, biological plant, industrial plant, bank, river bank, or financial bank. So these are called semantic level ambiguity. So the plant means it's a noun, but one says about the biological plant, one says about industrial plant. So based on the nearby words or based on the context, it changes. Okay, so this is called ambiguity. Now I'll start with the the deep learning part. So now so far I just introduced what is language processing, what are the challenges in the language processing. Now slightly we are moving to the other domain called the deep learning. So here we will see that what are the deep learning concepts, and then how we can bridge that NLP and deep learning. So the three part, the lecture can be divided into four part. One we are completed, NLP we are completed. Next I'm going to introduce you what is deep learning, then the bridge between the NLP and deep learning, and the last one is certain applications with NLP and deep learning. This four part I can say that the complete lecture. Now I have completed one. Now I'm moving to the second part of the lecture. So what we are talking, we are going to introduce deep learning. So when you are saying the deep learning, I talked about the term called artificial intelligence. So it's a very popular word now, buzzword. So the reason for that is actually deep learning. So that because of the deep learning and because of the computational power, whatever we are having, and storage, whatever we are having, that's the reason why that AI become popular. As I said earlier, AI is a not new term to us. AI is a term coined in 1950. AI, the term coined by a famous person, mathematician Alan Turing, in 1947. See the year. So the first India world's first computer is 1946. World's first computer is 1946. Alan Turing, he proposes the concept of AI in 1947. 46 is the first computer, and see that within a year, within a 1 year, we have the things moved. I mean, within 1 year, people coined the term AI. So there are a lot of booms of AI. So what we are having now with respect to deep learning and machine learning is the third boom of AI. I would like to spend some time on introducing the other thing also, how that AI emerged. Initially, AI is called a reasoning and then a knowledge-based model based on the rules it will work. People thought in 1950s, people thought that so we can solve any problem, any real-time problem with the help of AI. But later they identified that we cannot solve all the problems with the help of AI due to limitations with the algorithm and limitation with the data and then with the rules. So like that, that's first boom is a reasoning and knowledge-based model. So then after that, people understood that the AI is not that much popular. It goes to the stream. So after that, the second boom comes when a person, Fukushima, invented the neural networks. 1980, neural network is coming into picture. So after this one, people started again applying all the AI technologies. This is popular because of neural networks. But unfortunately, after some time, 80s it started, 10 years. After 90, people started finding the drawbacks and flaws and limitations in the neural network. And due to that, its poor performance to the certain problems, they stopped working on they stopped, they are not completely closing or doing. The less number of research will happen on neural networks. Now you see that now how many people are applying SVM to your model. Now all are going behind CNN, RNN, LSTM kind of models. So like that. After some time, after 90s, why that 90s it happened? The 90s, the important model, the type of machine learning comes into picture, kernel methods. The kernel method, the famous kernel method is called SVM, which is one of the popular machine learning algorithm, as we are aware. So 80s it started, it's about 90s it started. 91 it's introduced by Bapnik. So After SVM, if you closely see that SVM achieved wonderful performance and then state-of-art results for most of the, and not only the NLP tasks, computer vision, video processing, audio processing, bioinformatics, and most of the tasks. After some point of time, after what people understand, there are some issues with SVM also. Issues means we cannot improve further. So due to that limitations, people started, they haven't stopped using that. People started looking for other algorithms. So that time, in one fine day, a professor from University of Toronto, Hinton, he coming with a concept called deep learning. 2006, he published a paper on deep learning. After that paper, deep learning started emerging. So this is called, that is called as a third boom of AI. This is how deep learning and AI, how comes into picture. AI is a superset, and where the subset is machine learning. The subset of machine learning is called deep learning. So this is the difference. This is the relation between AI and machine learning and deep learning. So deep learning is a subset of machine learning model. Okay, so this we have seen that. Now we are seeing with respect to a year, we closely see that, as I said earlier, 1950s, AI started, till 80 AI ruled the world. Once neural network comes into picture, people understanding the importance of machine learning. So from 80s to 2010, neural network and the other machine learning algorithms, including SVM, rules the world. After that, now the world moved to the deep learning. 2010 onwards, it moved to the deep learning. Okay, so I hope you people are aware about machine learning and then deep learning. So I want to I'll just directly go to the difference between the machine learning and deep learning. So what is machine learning? Can any quick answer from the faculty members? What is machine learning? We don't have time. What is machine learning? Quick answers in chat box. What is machine learning? Any answers? Algorithms learns from training data. Okay. Why we want to learn from the training data? Any reason for that? Participants? Generalization. Algorithms learns from training to get generalization. So you want to build some generalization algorithm. Fine. Okay. Generalization. The partially it's correct answer. Okay. One more question actually slightly related to that. Like machine learning, what else is there? Let me answer. Give training to machine for fast. Okay, you are training the machine to do the operation. Okay, to do the things fast. Okay, fine. Okay, what are the other allied areas related to machine learning? Any idea? Any idea how that machine learning allied areas? Okay, so I'll just take one well-known area to compare with you people. So I'll take the term programming. I hope you're aware about the programming. I just spend some time on this. Then it's easy for you to understand. So that if you see that programming, so what is happening in the programming? So when the programming comes into picture, so still people are, I'm saying that people are saying that I want to say a few things here when I'm talking about the programming. People are telling that, sir, shall I learn Java or Python? Shall I learn Python or R? So what is there in learning multiple languages? That's the one thing. And if you know if you are talking about the programming languages, so programming languages in my perspective, only two components. One is a logic, other one is a syntax. So you are mapping the logic to the syntax. You have whatever logic you are having, you are converting to the language syntax. Your logic remains same. No one change the logic. No one change your thinking. Only thing is you are converting the syntax. Now you know the Python. Okay, the syntax, it means that you know the syntax. Tomorrow new language comes, you are raising the syntax and then you are learning the new syntax, how to apply that. But the usage on other things and how to apply the logic, and that is from your mind, that is your knowledge. Fine. That is a program, that is a programming. And other point, initially when computer, one point I want to say about the programming, this is the thing. So programming, so we don't say that I know this programming, I don't know that programming. It's, if you know one program, it means that 50% completed. If you know any one programming languages, it means that in the world, in all the programming languages, whatever is there in the world, you know 50% of it. Because each language is only the 50% component is a logic. So you have the knowledge about predefined knowledge with the logic. Fine. So the next point I want to say is about so this point about the programming. Then other point I want to say is sorry, it comes to me. Okay. Okay, so we'll come to the machine learning. Okay, so yeah, computers and then the deep learning, the importance of this one. So earlier days when the computers introduced, people thought that only computer scientists can handle computers, only computer specialists can handle computers. Is it a way now? Now you see that everywhere computers will be there. Now everywhere computers are there. It's not the computer is not related to computer science domain. Everywhere it's there. Am I correct? Okay, like that the programming. People thought that programming is a computer science field. If you are asking me, definitely I'll say that no, programming is not a computer science field. So you are in computer science curriculum, you are teaching programming. So it doesn't mean that programming belongs to computer science field, because now doctors are learning programming. So programming is also a common area. It's become a common. How computers became the common, like that the programming is now common. Program is common. Any field, doctors are, as I said, doctors are learning. Any people from the different various field, they can learn the programming and then they can do whatever they want. So that is also become like computer, the programming. Now the third one is this AI or the machine learning. The machine learning or AI is also definitely not related to computer science field. So what is computer science then? See that initially we thought computers are computer science. No. Programming. No. This machine learning. No. In future, the study says that maybe in a near future, if you see that as you people are faculty members, you know that how the admission process and everything is going on. The first filling seats are always computer science. So it doesn't mean that computer science is popular. Definitely, it means that computing is popular. Computing, I hope that you are aware the difference. Computing and then computational things are popular. Popular means that computational engineering, I mean computational information, computational engineering or computational intelligence are important. We don't have computational intelligence or AI. AI, now the people started courses on AI to accommodate the people on AI. But that is AI. My feeling is AI. You can make it as I mean first a computer science concept and then like AI. Now if you closely see that the people who are not computers are getting computer science, they used to see go for IT. Now people are not getting computer science or IT. I mean, AI, for AI, there will be a crush from the different people. Some 50% people will join. Remaining people are who are not getting and they will go. And what about remaining core branches? Mechanical, even the top institutes in India are failing to fill these, the core departments called mechanical, civil, even started in electronics also. So that is a case now. So what the future will be? The future will be only one computers, only a computer science. That's the future. It means that you don't think that other things are not there. If it means that, if I say that only computer science means computer science will be everywhere, means computer science will be removed. That is the meaning. Computer science will be computing will be a component of all other departments. Computer science separate department may not be required. Computing, that is the future. Now that started in abroad. If you see the curriculum, now the curriculums are coming like that. Mechanical engineering with computer science, mechanical with the computing. So it will give attractiveness, even though you have willing to do something in a computer science for mechanical. It's kind of multidisciplinary things. So where the computer is going to add like that. If it's added like this, mechanical with computing and easy with computing, and then finally if you see that there will be no takers for pure computer science. That is a future. That is a future going to come. So it doesn't mean that computer science nowhere exists. It will exist in everywhere. Like the same thing is going to happen in the internet also. Now 60% things are connected with internet. remaining 40% devices are not connected. Once in 2025 or 30, remaining 40% electronic devices also connected with internet means, then you no need to internet. It means that internet is not there. It's equal to that internet is everywhere. I'm trying to say that internet is everywhere. So there is no specific component internet is not required. Your phones may come without that internet switch on or off button. Automatically the default should be that with internet connection. That may be the future. You see, that means that we will be connected with every device. So where if you see that time, that generation 2030 or somewhere, if you're asking about the internet and all, people don't know. That's what I said, that internet is nowhere exists. At the same time, everywhere it's like the same thing is going to happen for computer science. Fine. So as I said that about how the computer and then how the programming are related to the machine learning and deep learning. So my point why I started with the programming is people thought that we can solve all the problems with the programming, but certain things we cannot solve with the help of programming. Complex things we cannot solve with the help of programming. If I'm asking you to write a factorial, you can. Like a Fibonacci, you can. I'm explaining some procedure. This is a software I want. This is a mod. This is a JavaScript. This is an option button. This button should do like this. You can. But what is complex? So whatever I'm explaining, a programmer can implement. Am I correct? Whatever I'm explaining, I'm giving as a requirements. So whatever I'm putting in a requirements, whatever I want, requirement modeling. So I'm just, anyone can build anyone can create or develop a program or applications. Certain things human cannot explain. Certain things human knows how to do that, but they cannot describe it. Say some example, any example from participant side. Certain things, I'm saying that human know how to do it because human brain is doing it, but they fail to explain or they fail to describe. Give some example for this. Participants, if you are facing problem in audio, please put in a chat box. I hope I'm audible. You people are actively listening that. Yes? No answers from describe brain universe. Okay. So that's the thing. So example, if instead of talking a big thing about a describe brain or describe the universe, simple, the understandable in the layman perspective, I can say that you are identifying the objects. You can see that you are seeing a computers, you are seeing a mobile phone, and then you are seeing lot of objects you are seeing, and then you can see that you are seeing the face of the person. From the face, you can recognize that who is that person. I am asking you to describe that, how you understand that this person is Professor Pawan. I am asking you to write a code to understand, write a code or write an application to understand Dr. Pawan. So it will require complex algorithm with only the limited accuracy. You can describe with the programming. I'm not saying you cannot. You can describe, but it will take a lot of time with the complicated rules. So it will be like his eyes will be like this. You have to write that. You have to convert it to programming, and he's like that. You have to hear. He will be like that, like that. So this is the features you are making it. Now, like that, how many people you are seeing? I'm asking you, how many people you know? How many people's name you know with the face and name? How many people you know? Say for example, 200 people. Is it possible for you to create all the 200 programs? So if you are started creating the program, 200 programs you have to create. But the programs are not depending to each other. One program will work for only Pawan, one program will only work for Anand, one program will only work for Kumar, like that. So there is no generalization concept here. Though there is no point of generalization. If you want to generalize it, difficult to generalize this case. So this is the point. So the point is actually you cannot describe how your brain recognizes the person, how your brain recognizes the object. So how that's what we cannot solve that kind of problem with the help of programming. That's what we are depending on machine learning. This is the reason why we are going behind machine learning or deep learning. So when you are saying that machine learning and deep learning, this is an important reason. So you cannot solve it. Okay, how you are solving this in machine learning? How your brain works? How your brain works? So how you recognize that this is Professor Pawan? I'm asking to that Redmi. Redmi, whether do you know Dr. Pawan, Professor Pawan earlier? No. Okay. How can you recognize? Suppose this week you people are participants are attending this 10 days or 1 week workshop. Next month or somewhere you are seeing Dr. Pawan. You can easily recognize him. Yeah, this is Dr. Pawan. I know him. I attended his seminar. I attended his EFTP. He's a coordinator. How your brain recognize that? Your brain stores all the information like that. Without seeing Pawan, can you identify that? You have seen this Professor Pawan for multiple times during the lectures, during the introductory speech. You have seen him, you have seen his face for more than 10 or 20 times. So that 10 or 20 images are recorded in your brain. When a new image of the Professor Pawan comes into your comes in front of you, you can easily recognize, yeah, this is Professor Pawan. So this is how that brain is working. So these 10 images or 20 images, what I said, these are called data. These are called experience, examples or samples. We are going to solve in the same way, because I trained your brain. You train, the brain is trained automatically. It has seen 20 points or images, then it's trained automatically how his look will be, but it cannot describe. It trained automatically. It have the weight values. The new image comes. It's extracting the pixel values. It's understand that using the earlier weight value. It identify that this is Dr. Pawan. Same thing we are going to do it with the algorithm. Instead of showing the 100 photos to you, I'm showing the 100 photos to the computer. 100 Professor Pawan photos I'm training the machine with the training machine. So and then I'm finding the machine. I'm asking the machine, wherever if you see, I'm making CCTV or somewhere I'm implementing, wherever if you see that the similar kind of images, I mean, if you are saying that, if you are saying Professor Pawan, if he is entering into the campus or he is entering into office, so just to give a indicate, you just to make a welcome note. You just to say that, hello, Dr. Pawan, welcome, like that. So this is called the machine learning. The same, the machine learning or the deep machine learning or deep learning, both are mimicking our brain. How people understood that how our brain is working, same thing they are mimicking in that machine learning and deep learning. Okay, so now I hope you are clear with what is machine learning and why we are studying or working on machine learning, and then what are the allied areas, the things. Okay, the difference when you are talking about the difference between the machine learning and deep learning. So there is a concept called feature extraction. Even though after giving the image, you have to say the algorithm, it means the classification algorithm, where to give importance, that you have to tell. So based on that only the system will decide. So suppose for example, I'm just doing the face recognition software where I'm just taking the multiple persons are there in the image, but you have to say that the system should, instead of your job is to identify the face, instead of looking all the features of the human, only you take the head features, only you take the face features of the human, only you take the face features. From the face features, you can go for classification. This face features are decided by human. There is an image processing. NLP, if you are taking, if you are going for the simple task called identifying whether the word is noun or verb. So I'm saying that you look left 2 words and then you see the right 2 words. Based on these 4 words, you decide. So this is a features. So these features only experts can give. If I'm asking you to give NLP features, it's difficult for you to give. If you have expertise and then if you have some knowledge in NLP, then it's easy for to give the features later to NLP. So this is what, excuse me. this is what happening in machine learning. So you need some people or expert to extract the features from the data points. It's called a human expertise. In case of deep learning, it's alternate model, advanced model. So what it is saying is, I don't want features by human. I cannot depending on that human features. So why cannot we automate that? Why cannot we automate that features? Suppose I just simply give an example why deep learning is popular within the industries. So a company, if you take the big company, they may working in the multiple areas, starting from computer vision, bioinformatics, cybersecurity, IoT, like the multiple areas they are working. So, but if they want to extract the features for each one, they may require the expert in each field. But instead of that, if they are hiring one expert in a deep learning, without knowing ABCD of that data, they can make use of algorithm. Here you can see that they can make use of algorithm and they can extract the features. So this is what happening in the deep learning. So input data we are giving. So the feature, whatever feature given by the human, that is also taken to the system. It means that the algorithm is considering that and identifying the features, and algorithm is identifying the classes also. The combination of these two is the deep learning, or it's called as a feature learning model. That's the reason why we are calling deep learning as a feature learning model, where we can use machine learning and where we can use deep learning. If you have a small annotated data, you can use machine learning. If you have a large data set, preferably you can go for deep learning. So it's a very quick to train the model in machine learning, but as you know that it's computationally intensive to train the model in deep learning. So you need good GPU power and supercomputers to train. But nowadays GPUs are also accessible for all the people. A good number of open source GPU services are available, starting from Amazon AWS, Amazon Web Service, and then the other Google Cloud kind of thing. So that's feasible now. So other point is, if you try, we need to try different features and classifiers too. So if you want to achieve the best results, you need to try the different features and you need to try the different classifiers. But you can make a system to learn that component also. It will learn the features and learn the classifiers automatically. So here the accuracy is unlimited in the deep learning. Here the machine learning is, the problem is accuracy is limited. Okay, I hope I make myself clear about what is machine learning and then what is deep learning and how it differs, the main difference between the machine learning and deep learning. Fine. So now we just move to the I mean, to see that accuracy and data comparison with the deep learning and machine learning. If you see that what is happening in the machine learning algorithm, you are increasing the data at some point of time. Even though you are increasing the data much, the algorithm accuracy is saturated. It's not improving much. But deep learning is not like that. It's called a data hungry model. Whenever if you are increasing the data, definitely you can see that the accuracy will go down. So that's the reason why the deep learning popular in this current. Okay. So this is with respect to the Google trend, the keyword. 2010, you can see this top only 10%. So in 2017, if you closely see that 16 and 17, so it reached 100. People started applying in all the fields, wherever the data they are finding, they start applying the deep learning models. It's a famous person, and I hope some of you are aware that if you are searching for anarchy, his lectures will come. He is at the Google DeepMind. Now his statement, Andrew Ng, his statement about deep learning. I have worked all my life in machine learning. So his interesting lectures will be available in YouTube. You can see that. And I have never seen one algorithm knock over benchmarks like deep learning. So he is giving the statement that. So one algorithm for, as I said, that any domain, So it reached the machine learning deep learning model reached the benchmark. So now, so far we have completed the two parts. One, I started with the NLP. I introduced the NLP, and then I introduced the challenges in NLP. And then the second part, I just introduced what is deep learning, how the deep learning comes, what is behind that, what is the history of the deep learning we have seen, and we have seen that how it's different from machine learning. Now the third one, the third one is the bridge, and then fourth one is the application. These two are there. Now slowly we start with the application. I think, yeah. Now we'll start with the application. Later we'll go to the bridge. The third one is application. So these are some of the applications of natural language processing. So this is a pure NLP task. Natural language understanding is a type of natural language processing. So where you are talking about name entity recognition, relation extraction, extracting the relation between the words, between the sentences, sentiment analysis, saying positive or negative, parsing, finding the tree structure for the text, question answering, automatic question answering. You know, asking some question, then system should automatically answer that. And then translation, text categorization, and summarization. Summarization, there are a lot of applications in summarizations are available, particularly with the help of legal data analytics. When you are talking about the legal data, the what is using. So, can you mute someone? Audio is on, I think. Okay. So where the summarization, I'm talking about the legal data analytics. So where a case document may be 1,500 pages. So a judge may not have a time to read all 1,500 lines. Instead of that, they can identify that which part the system has to concentrate, and they can come up with a summarized model where they can utilize it properly. So these are a few. These are the few applications you can see that when in a machine learning and in I mean with respect to the deep learning. So this is a one interesting application. We are taking the tweet, and then you can see here the emotion of the tweet we have identified. So you can see the emotion. Yeah, you can see the emotion. Literally, your Facebook message app is useless and you want it to increase profit. Please fix yourself. It's sad, Facebook. So the emotion is frustrated. The user is frustrated. Tone is negative. So whatever here conveying is in the negative sense, subjective, negative. And you can see that the other features like the organization. So I'm talking about the organization Facebook. And I'm talking about the product of the organization is the messenger app. And I'm using the adjectives are useless and sad. So language what I'm using is English, which is informal English. So I'm asking a question now to the participants to check whether they are active or not. So here, what is informal? Why this tweet is called informal English? Simple question. Why this tweet is called informal English? Participants, quickly in the chat box. Why this is called informal English? That's a question. Hello, participants, are you there? End of use. Where it's end of use. Useless they have, okay. Why I'm saying that informal? That's not a clue, right answer. Just a try, it's a simple question only. No? Any other answers? Ease of use, ease of thought. Closely see that. If you are sending a mail to higher authorities, then I mean you know the difference between formal and informal. When you are sending the message to a friend, you used to be an informal. But when you are sending a message to your higher authorities, we should be make it a formal. Whether this kind of this statement, this sentence, if you want to send to the higher authority, whether you use this text, see the each and every word carefully. So what was that answer? So you are, see the term you are, literally your Facebook. So your, YOUR is the correct form, formal one. And this is the called as informal. Yeah, that's the reason we are telling this tweet is informal content. Okay, so when you are coming to the use case with respect to healthcare, there are a lot of interesting applications you can do. It started from the patient stratification, so it means that it's identifying the identifying or grouping of patient. It's like a patient profiling and clinical document improvement. You are improving the clinical document. So once the clinical documents are improved, then it's easy for retrieve. Similar kind of cases were handled in the 3 years back. So what treatment we have given? What was the diagnosis thing we have given? What is the accuracy? So one has to see that they can refer. But instead of searching from the papers, that should be documented, and then that should be converted as a structured one, and that should be pasted. I mean, that should be stored properly. So other things are financial risk, identifying the financial risk. What is mean by identifying financial risk here? So, but now they have a, I mean, the hospitals require a system. So to see that if this kind of diagnosis they are coming, and then what may be the approximate financial commitment we should ask, and you can even relate that with your insurance schemes and other things. So predict the outcomes. So you can predict the outcomes. So this is a case for how the COVID spread you are predicting. Start from that, and then based on the COVID post, you can say that whether that COVID is there in this particular region or not. Quality measures. So this is a one way of the important one to improve the healthcare industry. Fine. So other related application specific thing, if you see that a speech recognition system, so the voice assistant you may require, and the documentation, computer assisted coding. So where you can use that with the help of partial NLP commands also, because as I said earlier, doctors started using programming. Instead of asking them to completely use the programming, let them use few natural language statements also, not completely, few. Okay, another one is automated registry reporting. So this is about the registration. Okay, so clinical trial matching. So matching with patient profile based on the diagnosis. So based on their food habit, based on the things, if they are having a problem now, if any kind of same profile comes to their hospital, they can warn them. So if this kind of same profile with the same clinical trial, people got this particular disease. If you are not following, if you are following the same habits, then you will also get the same. So the prior authorization decision support system, we have seen that, and which was Skype. Okay. Okay, this is what application we are discussing. We have seen that NLP with respect to healthcare. So I want to spend some time here actually NLP with respect to education. Now, particularly in online education. So where you are facing, where can you say any application with respect to NLP and education? Not saying this one. Where the NLP can useful in education, particularly this kind of COVID situation, where we can use quick answers, 30 seconds time. Participants? Participants, are you people are here? If you are really, if you are here, can you put can you type yes in the chat box? I'll see that how many people are active. So around 41 people, 41 participants are there. I want to see that how many. Yeah, 2, 3. Thank you, Redmi. Thank you, Balachandra, Monica, Balamurugan. Only 4, 5, Rupa. Okay, for listening. That's it. Not even 10%. Okay, 40 people, 10%. Okay, go ahead. Fine. Okay, fine. So, other people's or people are active. Okay, I asked the question. So, what can be the related NLP application with respect to education domain? So, you are working in education domain. I mean, you are in academia and you know what is NLP. Can you find any application of NLP in education or academia? Participants? Chatbots, yeah, that's an interesting answer. Can say the NLP chatbots we can make. Okay. Any other? Online assessment, yeah, very good. So what we are facing now, we are forced to go with the exams like multiple choice question. So that should be avoided. So even if the student is writing a 2-line or 3-line answer, we should have an automatic system to analyze that result or to find out to give marks to their answers. Any other answers? Result analysis, automatic result prediction, feedback analysis from the sentiment. Any other answers? So online assessment. Okay. So one of the tough job, if you ask as a faculty, if you are asking me to take a class 2-3 hours extra, fine, I can do it. But if you are asking me to correct papers, now here we are having 110 students in a class, so I have to correct 110 papers just to see that. As you know that you people are one of the toughest job, one of the boring job to us is to correcting the paper. The drawback to what happen is, whatever there in your mind, suppose I'm asking you to define the NLP. If I'm correcting the 101 definition of NLP, after finishing the paper correction, definitely we'll come to that. If you are asking me what is NLP definition, so I cannot tell. So whatever is there in my mind, it will be completely wrapped after seeing the answers from the students. So that is one of the boring job. So that should be automated. So we should have some system with the help of NLP to automate that. Okay, so when you're coming to that NLP in education, the one, as I said, is that innovative education applications. So you can create language specific applications, particularly teaching the language classes or grammars. Educational chatbots, as you Rupa ma'am said that. So chatbots, educational chatbots we can build. So even you can try education chatbot for particular domain. Say for example database, you can build a chatbot. Student is having any query or any clarification to database. If he is posting that, and the system should automatically identify the answer. Let it from their knowledge, or the chatbot let it search from the internet or validated resources and the references. It should bring the answers. It's an educational chatbot. That is an interesting application. Automatic answer grading, quality assessment. That's what, as I said there. So where the plagiarism checking also one of the important one. So definitely we are not happy with the current plagiarism checker, whatever we are having. So you know that how much it won't capture the synonymous words. It won't capture the paraphrased sentences. So the automatic question exercise generation. So I'm working in one of the one international project with one US-based company. So they want me to, I'm working on it actually. So they want me to build an education related NLP application. So where that is actually comes under the exercise generation and automatic question generation. And it's not exactly that. So it's a simple one actually, but it's based on NLP. So finding the questions and answers from the unstructured documents. So from the PDF and then or from the documents or from the assignments or the things, your job is to identify which is question, which is answer, which is image, which is table, like that. That's an interesting application. We are working on it. We are on the verge to complete. I think this month end is a deadline. We are going to complete that project. So that is a one NLP in education application. That is the future it will come actually. So an automatic question exercise generation. Now, the main problem what the government is also facing is how to select, how to fix the questions for this particular exam. Now they have a system of randomly selecting. Randomly selecting means all maybe 5 or 10 professors will build the question paper, 50 to 100 questions will come. Machine automatically will generate the questions, generated 20, I mean, the number of questions or required number of questions. That's not a right way to do. Because if you are taking database questions and I'm taking database questions, definitely 10 to 20% overlapping will be there. So after getting the machine selected questions, a person has to manually check whether any overlapping is there or not. That is the randomness is used in question selection. So why don't you automatically generate the questions and generate the exercises? So you are giving the lecture notes to the computer. So computer should find out from the lecture notes, it should form the multiple choice questions. Say for example, so just now I remember, Pawan sir is asking me to send the questions. I haven't sent so far. So because I'm to be frank, the first job I hate is to correct the paper. The second job is to fit the question paper. That's all. Anyway, I have to send it. Anyway, today I'll send it. So this is what. So that also can be automated. So I'll give my notes. I'll give my presentations, or I'll give my videos. From my videos, you can see my the recordings. You can hear my voice. You can take the questions from that, or from my slides. So why don't we build automatically? Why don't we build questions from out of it? That's another interesting NLP application with respect to education academia. Behavioral analytics. So I have to analyze the behavior of students. I have to analyze the behavior of teachers from their answer sheets. So if a guy is very happy with the faculty, so the way how he is writing that exam will be completely different. If a guy, it's not the students are, as you, I hope you will agree with me, the students won't go with the subjects. Students go with faculty members. If they are happy with that faculty member, then they will use pencils for diagrams, sketches, they'll underline the main points and like that. If they are not happy, they least bother to write. Even though they know the question and they know the answers, they will write only 2-3 lines and then they won't show any interest. So this answer books shows some behavioral information or some feedback of the with respect to the faculty or the subject. Because even though all the education system we have that feedback system, people are getting feedback to the faculty and other thing. But that the students are giving genuine feedbacks. Only 10 to 20% people are giving genuine feedback. So whatever decision we are taking is based on only 20% people. That's true. Remaining 80% people, they don't have time to give the feedback. They are not, they're least bothered about to give the feedback. Randomly, they just click here and there, they'll type something and then. So, but if you are having the system like this, why you are asking student to do the feedback? You are based on the answer sheets, based on their assignments, based on the lab programs. You can based on the other. I mean, this I'm talking only about with respect to NLP. There are other parameters with respect to computer visions are available. Computer visions based on their interest, their face reaction in class, based on the sitting style, you can understand that. So this comes under the behavioral analytics. Okay, so the next interesting applications. So I just recall that what we are saying is, so we started with the NLP and then we started the next phase, 4 phases. I said that NLP completed. The next one I completed the deep learning introduction. Now I'm just connecting the deep learning with NLP, the applications. So this is the last slide of the application. There is a new application with respect to different domain. Now, after that, I just move to the how are you connecting this NLP and then deep learning. It means that how you are solving these applications, any one of the applications. That's a thing what I am having now. So I'm going to complete the third part of the first presentation. So this is the last slide of that. So NLP with respect to finance and agriculture. So other important component is agriculture. So as you know that the world actually it's moving, the government important thing, all the investment and the everything is now it's with the five components. One is the agriculture and education, and the other one is the energy. And now it's not coming to mistaking to my mind exactly what is education, agriculture, healthcare. Healthcare we are seeing with respect to NLP, and finance is the other component. Yeah, and we are not touching that energy part here. Anyway, energy and finance we can associate NLP with finance and agriculture. You see that with respect to finance, the sentiment analysis from the news, how that news content affect the stock market. That's interesting. How your tweets affecting the stock market. How the number of tweets affecting the stock market. It's an interesting area of analysis. Chatbots for financial investment suggestions, and chatbots for farmers, particularly in the regional languages. You can build a chatbox for farmers. You can build a chatbot for investment suggestions. Suppose I want to invest something, I'm explaining about myself, and then chatbot can automatically say that this will be the right option for you. Discovering crop, so with respect to the agriculture, discovering crop disease trend using farmer queries, analyzing the farmer queries and then understanding the crop diseases, terminology extraction for document matching and open. I mean, this is another interesting area where you are extracting the terminologies from the available agriculture data. So then you can finally you can make a dictionary kind of thing where a person having a doubt or something, they can automatically they can do the automatic search and then they can refer it. So these are the applications we have seen. Now I'm just completing the third portion of that first session. So NLP is over, deep learning is over, and the application is over. Now the bridge between deep learning and NLP. So one application I think I have missed here. Just to check quickly, I'll check whether I have at the end or not. Yeah, at the end I have your application, that application I explained. Fine. So when you are, now I just connecting that deep learning with NLP, how we can connect the deep learning with NLP. If you see that the deep learning with NLP connection, so you can see from the diagram what is happening. This is a traditional NLP model before deep learning. So there will be like a pre-processing step, modeling step, and then output classifier. But in a deep learning, there is no components like that. And then see that this each box is for each language. Tokenization, you have to do English, Spanish tokenization, Tamil tokenization, Telugu tokenization, stop word removal for Kannada, stop word removal for Malayalam, post tagging for like that for different languages, different language specific tools we require. But deep learning, you see that it's a very simple architecture. You don't worry about these building blocks, these models. So what is important here, what is the bridge is, this part is NLP, this part is NLP, and this part onwards, it's a deep learning, but this is the bridging point. This is the bridging point. So this part explains the how NLP can connect with the deep learning model. So we are calling as a dense embedding. We'll see that what is dense embedding. Okay. Before saying to this, I explained what is machine learning also. So what is machine learning? How machine learning will take input? Quick answer. How machine learning will take input and then how it will understand from the input. Answer from participants, 30 seconds. Even if it's wrong, it's don't mind. Just answer it. I'll come to know that you are listening at least. Any answers from participants? Okay. Any answers? What I asked is actually what is the input to the machine learning algorithm? How you will give input to the machine learning algorithm? So in the computer vision task, how you are giving input in image processing or biomedical processing, signal processing, how you are giving input to the uploading files. So system will capable of understanding the files. You mean to say that so machine learning algorithm will understand the files, the content in your file. Do you mean this? Do you mean to say the same, Balachandra? So what the content of the file can be understood. Suppose you are giving the image, machine learning algorithm will understand the image. How will understand the image? Load the dataset is a step what we are following in the coding part. CSV files are the file type. How the content goes to the machine learning algorithm. Content means I mean to say the text or images. Number format, yeah, Balamurugan, yeah. So the machine learning algorithm will only accept the number format. Why it's only you are correct? Why it's only accepting the number format? Why it's not accepting the file or data or image or text? This question to all: why machine learning algorithm accepting number format? Only a number format. Okay, the reason is machine learning is nothing but a mathematical model. Numerical computation. Yes, machine learning is mathematical model, and we are doing the numerical computation. What we are doing is we are solving the set of equations. We are solving the set of equations. So that's what we are doing. So to solve the set of equations, so you cannot directly access the text or images. So you are waiting for numbers. So whatever images you are giving to your model, whatever the uploading files and uploading CSV files, everything will be converted to a numerical values. This numerical values only will pass to the machine learning algorithm. So when we are passing that information, when we are passing that machine learning information, it means that numerical format is, as you said that, it means that numbers. In case of image processing, how you are converting the image to numbers? How you are converting image to numbers in image processing? Participants, quick answer. Okay. No more answers. I'm asking about not NLP, image processing. You might have known that. No? How the image is converted to numerical format for machine learning. Conversion of images. That's what. How? Okay. The simple one for the image to numbers is actually pixel values. So whatever pixel values you are taking, so that is actually numbers. Image processing, the advantage is already the data set will be in a matrix format, structured format. So you can easily convert that into numbers. Pixels are meaningful numbers. Pixels are meaningful numbers. What about in text? Numbers we cannot take a random number. We should have some meaningful number. You have to prove that how the number is meaningful also. So the point here is why we need that word embedding. So this is what. So in NLP, the term, the mechanism to convert the word to numbers, word to vectors, it's called word to vec or word embeddings. So this is word to vec, word to numbers. I'm converting word to set of numbers. I'm converting word to meaningful numbers. See from here the diagram. You are giving a set of documents to the machine learning classifier. Machine learning classifier is predicting something like this. Each word and its numbers, equivalent numbers, or I can say that efficient relevant numbers. So how can you convert that? So why we are converting that, as I said, that we need some effective representation of not only the word to numbers, sometimes character to numbers, sentence to numbers, and document to numbers. So we want the text content to convert into numbers, meaningful numbers. So what is before this model? So before this model, there is a called a one-hot representation, and then other model is latent semantic analysis. There are drawbacks in this one-hot representation. So what is the drawback in one-hot representation means? Each word will be represented as a vocabulary of size V. So like this, each word will be represented as a vector like this. In that word's corresponding position will be 1, remaining position will be 0. Only the corresponding place will be 1, remaining position will be 0. So this is called one-hot vector, one-hot representation. There are a lot of drawbacks in this model. So for example, you want to find the similarity between two words, say hotel and motel. You know that these two words are somehow similar. But in this one-hot representation, if you are finding the distance between these two vectors, you are getting 0, or distance or a similarity between these two vectors. So system is saying that there is no similarity between these two numbers. But we know that there is a similarity. So the reason why it's not finding the similarity is it's due to this numbers, this one-hot representation. So one-hot representation is not efficient representation. The other model people tried is SVD. What is SVD? SVD, quick response. SVD. Anyone knows SVD? Okay, SVD means singular value decomposition. It's a linear algebra model. So where what we are doing here is we see that you have a matrix A. So you are decomposing the matrix into 3 matrices. From that, you are converting the A matrix to the low dimensional representation. You are reducing the dimension of the matrix. When you are not reducing the data, you are reducing the dimension of the matrix. So there are problems, its own problems in this model also. One is the computational cost. Other one is how to train for the new words. So this is solved in the word embedding model. This is the motivation behind the word embedding model. Why we are working on this word embedding. And this is a statement by a famous person, Firth. So his statement in 1957, the algorithm is working on this principle. So you can see his principle, what he has given. You shall know a word by the company it keeps. What does it mean? What is friends? You can know a word by the company it keeps. What is the meaning of this sentence? Any answers from participants? What is this meaning? I haven't asked any different language. No, I'm asking only English. Even it's wrong, it's fine. As I said earlier, let it be a little bit interactive. Then it's a. How can I know that you people are listening? Okay, some answers. Thank you. Thank you, Redmi brand. Camp tagline. What is that? You shall know a word by the company it keeps. What is it? Camp tagline. How can you say that you shall know? The company means here that it's called as a context. So you can understand the word based on the nearby words in the corpus. Based on the nearby words, you can understand the word. That is the meaning of this one. You can understand the word based on the nearby words. The nearby words is a context. It's nothing but context. You shall know the word by the company it keeps. The complete algorithm is working on this principle. You shall know a word by the company it keeps. So the complete algorithm is working on the same principle. So this is the context. With the context, you can understand the word. That is the principle behind that. We see that how it's working with that principle. So what we can do is we are representing the each word in a low dimensional representation, word to word. So Pawan sir, how many minutes left for me?
Actually, you are taking extra minute 4 minutes, sir.
Okay, so because I started a little late, can I continue for 10 more minutes and then continue in the afternoon session?
You can continue in the afternoon session, sir.
Okay, so you mean to say that I want to stop now?
Yeah, I mean, in another 5 minutes, or if you are in flow, you can continue, sir. Otherwise, as you wish.
No problem. That's what I'm starting the new thing here. So I'll do one thing. I'll continue in the afternoon session.
Okay, so, sir, fine, sir.
Okay. Thank you. Thank you, participants. Any questions? So I'll continue this distributional semantics afternoon. So far I covered the three things. NLP covered, deep learning I covered, and then I covered the applications of NLP. I have a few more applications that I will explain at the end. And afternoon we'll see that few more application, and then we'll see the demo also. I'll show the I'll take one NLP code with respect to deep learning, and then I'll explain the models, how it's working and all. And the bridge between the NLP and the deep learning. So we should take some time on it. It's not a theoretical one to understand the algorithm. Two algorithms, simple algorithm is there. That's what I asked here, sir, that. So I'll continue this algorithm afternoon. After that, if time permits, so we'll see the interesting NLP application, the recent NLP applications with respect to the cyber, and the cyberbullying. So if time permits, I'll continue that, or I'll directly go to the demo. So now it's if you have any questions or discussion, you can ask.
Participants have any questions, please raise the questions, if anything. Otherwise, you can ask the questions even in the afternoon also. The query session will be there at the end of the session, 10 before the closing the session in the afternoon. Any participants? Yeah, you can continue in the afternoon, sir, I think.
Yeah, sure, sir. Afternoon, 2 o'clock, we'll start sharp now, sir.
Okay.
2 to 4.
Yeah, sharp start. Just 2 to 4.
2 to 4. So
participants are requested to join at 2 o'clock. Yeah,
2 o'clock we'll start, because already we missed some 15-20 minutes earlier morning. So we'll start exactly at 2 o'clock. Please, participant, please join me at 2 o'clock. So 2 to 3:50, I will stop, and 10 minutes we'll have for a discussion. Okay, sir. Okay, thank you. Thank you all.
Thank you. Meeting is closed.